This question is about the law of conservation of momentum and taken from the 2024 May TZ2. And in this question, they say that there are the two blocks. There are the two cars. The one has a 1 kg and the other one has a 3 times more weight than the last one, but it is at rest. So I can say its initial velocity is 0 meter per second, but its initial velocity is u1 is 4 meter per second. So it is approaching the second cart, and after collision, what information they give us that they stick together, which means, dear students, that first of all, it is a perfectly inelastic collision. But even in this inelastic collision, we know if there is a no external force exerted on the system, then the change of momentum of system is zero. It means that you can apply law of conservation of momentum, but energy will be lost, and that will be lost in the form of the other energies, sound and a small amount of heat. Okay, now we are going to give this scenario a name, that this is the after collision situation, and I will draw another diagram that will represent a situation after collision. So this is this is a before collision. So students, this is a situation in which we see that these two cars now stick together, and now they are moving with relatively slower but with a common velocity, which we can calculate later. And in this question, we have to find out what is a ratio of the energy lost. I mean, what is a kinetic energy after collision divided by kinetic energy before collision. But you cannot approach this thing directly unless you apply law of conservation of momentum, because that empowers you to find out that what will be the velocity after collision. So first of all, because I have already told you that there is a no external force exerted on system, that's why we can apply law of conservation of momentum, which says that the total momentum before collision. Now the total momentum before collision means the momentum of the first card plus the momentum of the second card must be equals to the total momentum after collision. So the momentum of the first card plus the momentum of the second card. Do you see that I'm not writing v1 and v2 because these two are moving with same velocity as a system, and secondly, this is 0 because it was at rest. So if we plug the values, which is so simple, that 1 into 4 is equals to this is a v into 1 plus 3. Okay, so that is 4 is equals to 4v, and that gives us the common velocity is 1 meter per second. This is a speed of this two cars. So obviously I told you that this is an inelastic collision, so some energy is lost. So let's calculate what was the total kinetic energy before collision. So students, the total kinetic energy before collision is only due to the first moving card. So half into 1, that is a mass, into its velocity square. So that is 16 divided by 2 is equals to 8 joules, right? And what is a kinetic energy after the collision? So 1 over 2 into what is the total mass of the system, that is 4, into its velocity that we have calculated 1 meter per second. So let's take a square, so it will give you 2 joules answer. Finally, let us put the value here. The total energy after collision is 2 joule divided by total energy before collision is 8 joules. So answer is 1 over 4. So right answer is option C.